All right, let's talk about a toolkit that is going to completely change how you troubleshoot APIs, Postman collections, and environments. If you're an IT support or an engineer who wants to get way faster and way smarter with diagnostics, you are in exactly the right place. Let's dive in.
But first, I have a serious question for you. Just think about it for a second. How much of your day is eaten up by that boring cycle of logging in somewhere, grabbing a super long token, pasting it into another request, only for it to expire 5 minutes later? Yeah, we're going to put a stop to that, starting now.
You probably know this scene all too well. Your Postman window is just a sea of untitled, unsaved tabs. You're constantly juggling URLs and API keys, and then you get that ticket, the one with a super complex, multi-step bug that you have no idea how to reproduce. It's a grind. It's chaotic, it's slow, and honestly, it's just frustrating. So our first step out of that chaos is simply getting organized. In Postman, this means using collections. Now, don't just think of these as folders for your requests. They're way more powerful than that. Think of them like living executable playbooks for your APIs. And setting one up is incredibly easy. First, you just create a collection and give it a name that actually means something, like Payment API Troubleshooting. Then you start saving your individual requests into it. And here's the crucial part. You group them into folders that match a real-world process. Trust me, when a real incident is happening, having this structure is an absolute lifesaver. Okay, so your requests are organized. Fantastic. But what about when you need to test against different servers? You're not going to manually edit the URL and API key every time you switch from staging to production, are you? That's slow, and you're bound to make a mistake. This is where our second hero, environments, comes into play. And this just shows you how beautifully simple it is. On the left, you've got your staging setup. On the right, production. Notice how the variable names like base URL are the same, but the values, the actual URLs and keys, are different. This lets you switch your entire collection's target from staging to prod with a single click of a dropdown. No more digging through request settings. So all an environment variable is, really, is a clever placeholder. When you type /base URL into your request, Postman just looks at which environment you've selected, staging, prod, whatever, and it grabs the correct value and swaps it in just before it sends the request. It's totally dynamic and crazy efficient. Now for my favorite part, automation. We're going to solve that annoying token problem once and for all, using something called a pre-request script. Don't worry, it's just a tiny piece of code that Postman runs for you before it sends your request. You know this dance, that soul-crushing cycle. Run the login request, squint to find the token, highlight it just right, copy, click to another tab, find the auth header, paste, send, and then do it all over again 5 minutes later. What a waste of time. This one little line of code is your ticket out of that misery. You just add this snippet to the Tests tab of your login requests. All it does is tell Postman, hey, after you get a successful login response, find the thing called token in the data and automatically save its value to a variable named bearer_token. That's it. And the result feels like actual magic. You run your login request one time, the token gets saved automatically in the background. Now, every other request in your collection that uses the $bearer token variable will always have the freshest, most valid token. You don't even have to think about it. It just works. Okay, so our workflow is organized and our authentication is automated. But is the API actually working correctly? Let's stop just staring at the JSON response and trying to spot errors. It's time to let Postman do the checking for us using some very simple test scripts. And you absolutely do not need to be a coding genius to do this. Postman makes it so easy. The first part, pm.test, is just you giving your test a name in plain English. The next part, the assertion, does exactly what it says. It checks if the response status was 200 OK. And the last one just checks, hey, does the user ID field actually exist in the data we got back? These little checks are simple, but they are so powerful. So let's put all the pieces together. We're going to see how collections, environments, and tests combine to turn you into a troubleshooting superhero. We're going to use a feature called the collection runner to solve a tricky, real-world problem. So here's the ticket that just landed on your desk. The payment API is acting up on the staging server. A customer says their payments are failing sometimes, but not every time. Ugh, the worst kind of bug to track down manually. And the problem isn't just one API call. It's a whole 5-step workflow. You have to log in, get user details, create a payment intent, submit the payment, and then verify its status. The key here is that each step depends on data from the step before it, like a line of dominoes.
So, instead of clicking send 5 times and manually copying and pasting IDs between each step, our engineer simply opens the collection runner. They choose their payment API collection, select the staging environment from the dropdown, and click one button, Run.
And bam! Seconds later, the results are in. The runner just executed all 5 steps in perfect order, automatically handling all the data handoffs. And look at that. Steps 1 and 2 passed, but step 3 is bright red. It failed. We've instantly found the exact point of failure in this entire complex workflow.
And because of that little test we wrote earlier, we know exactly why it failed. Our test for step 3 was checking to make sure a transaction ID field existed in the response. The test failed, which tells us the ID was missing. That's the smoking gun. Step 4 was failing because it never got the ID it needed from step 3.
Now, this is the perfect handoff. The engineer can export these results and attach them right to the developer ticket. It's a portable bug report. It has indisputable proof of the failure, the exact request to reproduce it, and the test that caught the error. This changes the conversation from, hey, something's broken, to, hey, the transaction ID is missing in the response from this specific call. Here's the proof. This is how you cut debugging time from hours down to minutes.
So there you have it. From total chaos to complete clarity. By organizing with collections, managing context with environments, and automating with scripts, you can solve issues faster and give your team clear, data-driven proof. So the only question left for you is, what repetitive workflow will you automate first?